All right. Here we are. We'll call this 7-3. Day 2, part 2. And like we talked about in the first day, the piece that you're going to see here is really going to come up on F and G. That's new. Cases where you have a squared trig function where we need to do some factoring. Okay, this first one, not really going to happen because we don't have a linear trig term. So this is kind of like day 1. Secant squared theta equals 1. We'll take our square root and get that secant theta is plus or minus 1. Okay. Well, we don't like secant. It's not that we don't like it. It's just, we don't like to solve with it. Okay, we don't like it. It's fine. It's no hard feelings, secant, but we like cosine better. Now, kind of funny here, plus or minus 1. That's like 1 over 1, right? Think of that as a fraction, and you flip it, and kind of a weird scenario. The number it's equal to actually doesn't change. It's still just plus or minus 1, which, no big deal. This gives us 2 scenarios we got to solve. The first would be cosine of theta equals 1, which means we need to do an inverse. We're talking radians right now, but this is unit circle friendly. The only place on the unit circle you find a cosine value of 1 is at 0 radians. And then we'll do cosine inverse of negative 1. Also unit circle friendly, and the only place cosine is negative 1 would be at pi. And there you have it. Really, more or less, that's a review of day 1. If you're looking at that one and you're like, oh, 7-3 day 2, part 2. Was expecting something new. Didn't really see it there. Yeah, you're right. Nothing mind-blowing in that one. F and G, different story. Okay? We've got some factoring to do. So, let's do it. 14 cosine, right, plus, 14 cosine squared plus cosine minus 3. Okay, this is the case where we have to factor because we see we've got a cosine squared and a cosine to the first, okay? I'm pretty sure that leading term will get split up 7 and 2. Seven and 2. Okay. Now I got to figure out what to do with the minus 3 because I got to get a middle term of positive 1. Got to get a positive term. So if I put a plus 1 there, that'll get multiplied by 7. If I put a minus 3 there, that'll get multiplied by 2 and give me negative 6. I'm limiting how much space I get to use on this one. Got to leave a little room for part G, right? Just a little. Okay. We've got it factored. 7 cosine theta minus 3 times 2 cosine theta plus 1. Right? Again, we've practiced factoring trig functions. If you wanted to ignore the cosines and just say that those are x's, you could take them out and then put them back in if that helps you factor. Okay? Now, this plays out one factor at a time. So first, I'm going to deal with this. And really, the new piece is the factoring. Once we've got that done, you shouldn't see really anything new, right? From from here, I'm going to solve 7 cosine theta minus 3 equals 0. We won't see anything in this process that we haven't already seen. Right, I'm adding 3, dividing by 7. Remember, that's all aimed at the trig function. Needs to get by itself, and it is, okay? Three over 7, not on the unit circle. Not on the unit circle. Use a calculator for that. Take the inverse, round it to the nearest hundredth, right? Make sure you're in radian mode. About 1.13. With cosine, if you're talking radians, you would take 2 pi minus your first answer, and we'd get 5.15. Okay? Good news, bad news. Good news, for that factor, we've got our 2 solutions. Looks great. Bad news, because this, was originally like a quadratic form, and we had to factor it. We've got another factor that we need to solve, which is no big deal. Draw a line here just to separate that this is just separating this work that I'm starting on the other factor. I also need to solve 2 cosine theta plus 1 to get all of the solutions. Cosine theta equals -1/2, right? Even though the first answer didn't put us on the unit circle, this one does, right? -1/2. And this is that case I was talking about in day 1 where if we're expected to give exact answers, if it ends up on the unit circle, because we're talking radians, you got to recognize it here, because unlike degrees, where if you just put it in the calculator, you'll get the same answers that the unit circle would give you. Radians isn't going to do that, right? It would just give you decimals to approximate them. The unit circle would give me 2 pi over 3 and 4 pi over 3. So really it is, if you end up with a case that you can get solutions from the unit circle, it's important that you recognize that you can, okay? All right, I'm going to slide over a little bit to give us some room for 2 sine squared minus sine, okay? First thing I'm going to do here is move over the sine term. I can see right away this has a squared term and a linear term, right? And again, that means sine squared and then a sine to the first, all right? That makes me realize right away I need to factor. And any time we're factoring, right? We didn't have to do this in the last one because it was already set up this way. But any time we factor, got to be set equal to 0, okay? Which is why I moved over that sine term to the left, and now I factor. I've got 2 terms, and they have one thing in common. They both have sine theta. 2 sine theta minus 1 is what's left of the other factor. And now we kind of find ourselves in a similar situation as f. Okay, we factored, and from there, we can solve each factor separately. And again, from all the examples we've seen, these two aren't going to show anything new from this point. Okay, my first factor would be sine theta equals 0. That's a unit circle problem. 0 and pi would be the two places I'll get that. Then I get a sine value of 0. And just like that, I can move on to my second factor. 2 sine theta minus 1 equals 0. Add 1, divide by 2. And we get sine theta equals a half. And yet again, we wind up on the unit circle. That would be at pi over 6 and 5 pi over 6. Are the two places sine is -1. Okay. So again, really the whole point of taking off this part from the original video and making it part 2 is problem F and G, where you see we have quadratics with that linear term. If you recognize that, factor first. Okay, that's the big thing. Make sure you realize you got to factor first.